All right, everybody, welcome. This is the intro video for your trainer. Here, the image that you're looking at is the trainer that I have. There might be some slight differences between your trainer and mine, but overall, this is the structure. Like, for example, you might not have the red case that I have, or yellow, sorry, case that I have here. Your terminal blocks, which is what those are called, might not be blue, but overall, these should all be the components that you have. So let's walk through a few things first, just as far as the names of things, and then we'll get into checking for power. And then this also will help you when you have to troubleshoot your lab. When you're building your lab, if there's a problem when you try to start your motor, which is essentially what we're doing with every one of the labs, uh, before you contact me, we want to run through a checklist of troubleshooting first. And so this will help you with that. All right, so a few things that I want to just give you the names of. So as I'm indicating them later on through this video, you'll know what we're talking about. First, this is the power supply on the top right. This is what I was mentioning yesterday in lecture or whenever you're watching this video. And this is the AC to DC power supply. Incoming power, of course, is AC, provided by you at your home. And this converts it to DC. This is going to convert it to, and I'll put it here, power supply. And this is AC to DC. And this goes from 120 to 24 volts DC. All right, 120 AC to 24 volts DC. So that's our power supply. Right next to the power supply, I'll do this in red actually, not black, is our breaker. This is a 3 amp breaker, very low amperage breaker because this control circuit does not have relatively any amperage at all. So 3 amps, I think this might be the smallest that they were able to find. We could actually get away with a 1 amp breaker, but in the event of a short circuit, we do want the fuse that's right next to it, this little housing right here next to it. This is our 1 amp fuse. So in the event of a short circuit, we want this fuse to go and not so much the breaker tripped. So these are bringing or part of the power system. Just like the panel in the house and the breaker in the panel are the power system for a residential dwelling, these are the power systems for our control circuit. So you plug in power, and after the 120 is fed into the power supply and we get the 24 volt DC on the other end, this will give you the power that you're going to be using for your labs. All right, let me erase those things now, and we'll come back to that. Down here on the bottom right, this is you can call it a junction box or just a push button station. This is what we tend to call these. Although there's also lights here, so it's not just a push button station, but there are lights sometimes on push button stations. And so that's usually the name that we give this, a push button station. So starting from the right, we have over here on the far right, this is our emergency stop, or e-stop we like to call it. And then we have a series of, oops, I went too far, a series of buttons. We have the green push button, we have the blue push button, and we have the red push button. Right next to those two, we have our indicating lights, a green light and a red light. All right. So just getting familiar with the names and terminologies of those. More on that as we start to build into the labs. Right next to that, as I was pointing out earlier, this is called a terminal point. All right, and instead of splicing in motor control, because we want access to the conductors to be able to put our meter into them, and find out if there's voltage, find out if there's continuity, instead of splicing, because splicing would require us to remove the wire nut to be able to get to the conductive part of the wire, copper in most cases. This makes it easy for us to be able to probe into the terminal points and be able to access without having to remove wire nuts. Sometimes when you remove wire nuts, you also end up disconnecting wires, and this can have further problems added to the circuit. So for that reason, all of our wires get terminated onto this terminal block. These two on the right, these two on the right, and actually let me get rid of now the word terminal, or at least this arrow. These two on the far right of this terminal block are where our power ends up being. This is what we call L1, the red one, or whatever dark color they're using. I think they're still using red in most cases. And the clearer one, in my case, the tan one, it could be white for yours. This is L2. Now, it doesn't really matter. However, there is an order that we like to set this up, and this we'll explore more in lecture, but L1 is the positive side of this circuit, and L2 is the negative side of this circuit. I'm using positive and negative because we're working with DC voltage. However, if we were working with 120 volts, for example, then L1 would be the hot and L2 would be the neutral side. All right, so all of your labs, as you start to build the labs and terminate wires to components and etc., all of them will be starting from the terminal point. Never will we be bringing wires from the actual power supply. Even though the power supply is providing power for the circuit, instead of messing with the power supply, and this is standard for the industry as well, we don't want to be undoing things at the power supply. It's much easier to have a point somewhere in the control circuit where all of your wires come into one point and terminate. Again, this is done for troubleshooting reasons, just makes it easier to access every wire. All right, up here we have our 3 motor starters. For some of the labs, we're going to have the use of this one. This would be a single motor starter, and some of the labs will have use of that one. This is the forward and reversing motor starter. All right, these are called motor starters because essentially this is the component that closes the contacts and provides power to the motor. So we have a single motor starter when we're just starting one motor, and then we have the use of the forward and reversing motor starter when we want the motor to go in one direction and then that same motor go in the opposite direction, clockwise, counterclockwise, as you probably will call it, but in the industry we call that forward and reversing. All right, not up down, although it could be up down like an elevator, right? Still would be called forward and reverse. Clockwise, counterclockwise, if you're looking at a fan, for example, fan's going this way, fan goes the other ways. Okay, clockwise, counterclockwise, but still we reference that as forward and reverse. Now, these 3 that I've pointed out here are magnetic. All right, these are magnetic motor starters, meaning, and I'll write it here, magnetic, meaning inside they have that coil that I was referencing in lecture. That little coil sits inside those components, inside the shell of it. And so anytime you see the word magnetic, you are referencing a coil. So this is a magnetic motor starter, meaning electricity has to find its way to the coil so that the contacts close and then turn on the motor. The reason why I'm saying that is right next to it, this white one that's right next to it. This is not a magnetic motor starter. This is a manual motor starter. If you notice, there's a green button. Let me get rid of the lines there, and we're looking at the white one here. If you notice, there is a green button here and there is a red button here, meaning you can start and stop the motor manually from this particular motor starter. Now, it's not necessary to have a manual motor starter when you have magnetic motor starters, but of course this is a trainer providing, teaching ability for you guys. So we've put both of them in this control circuit. We may or may not use it throughout the labs. I have to look at all the labs to see. They have changed the labs a little bit from when I originally was teaching this course, but I don't think it's in play. But the main thing that I want to point out from this is just make sure, if you notice here, this green button is popped out right now. You want to make sure that that green button is completely pushed in. All right. The motor itself will eventually run through it the way they have it wired up in the trainer. So always make sure that that motor starter, the manual motor starter, has the green button pushed in. It is one of the troubleshooting things that I'll go through when I give you the list of how to troubleshoot this in the event that the motor is not starting. Because if that's popped out, it might look like everything is working correctly. You have your lights are turning on, you're hearing things click, motor should be turning on, but like this, that red button is pushed in, meaning it is in the stop position right now. So this trainer, even if I wired it correctly and pressed start on this motor, let's say the green start button here, this motor is not going to start because of that red button being pushed in. I would have to make sure that the green button is pushed in. So sometimes when you're working on this motor starter, magnetic motor starter here on the left, sometimes, and it's happened to me, you might see it in a video or two, where your palm just kind of touches that red button here. And it's very sensitive because it's a stop button in motors. Stop buttons in motors are very sensitive because they're stopping the motor, so it could be an emergency situation. It takes very little pressure to hit a stop button. Whereas, and you can do this as you guys are looking at this video right now, press the start button, you see it takes a little bit more force to push the start button in than it does to hit the stop button. You can barely touch that stop button and it'll pop. In other words, it'll shut off the motor. All right, so those are the main components that we're going to be using in all of our labs. As we go through, we'll get into a couple more things. Down here, we have a control relay, and we also have a timing relay. Control relays are just, and we'll get into this in the lecture, they're just another component that allows us to set up a control circuit to have extra functions, secondary motor starting, lights turn on while the motors are turned on. So it is a component that right now you don't have to worry about. Same thing with the timer. We'll wait till we get to the timer in lab and have it explained before we start using it in the labs. All right, so those are the main players outside of one last one, which is of course our little DC motor right there. It's a 24 volt DC motor, and it sits right in the middle, very small. But this is just to mimic a real motor system. All right. So let's go through, and by the way, you can pause this. You can definitely hit this E-stop to see how it operates. When you push the E-stop down, it will stay in the down position. You can see these arrows that I have here. This kind of tells us how to reset it. All right, you can go ahead and try that right now. Turn it right and it'll pop itself right out. Push and it'll hold in the push position or in the open position, and then when you twist it, it'll close back up. All right, we'll get into normally open and normally close in the lectures, but for right now you can just at the very least see the function of it. All right, so let's walk through how power gets distributed. One of the first things I want you to do now, and you can go ahead and pause the video, go get your meter. Turn your meter to DC. Make sure you're on DC. If you have your meter to AC, things are not going to work correctly. So that's one of the things you want to make sure that you're doing when you're troubleshooting your labs or when you're checking for voltage at any point in any system that is motor control. It's not just, standard house AC voltage 120, 240 or commercial buildings 480, 277 AC. You might have DC voltage in your control circuit, as I was mentioning in the lecture. So you always have to be aware of what your control voltage is. In this case, it's 24 volt DC. So make sure you have your meter turned to the DC setting. If you're not aware of which one that is, this is the AC setting is the one that looks like that. The DC setting should be the one with the straight line and the little broken lines. That's the DC setting for voltage. All right, so if you have that and you're ready to go, here's what I want you to do. This doesn't really matter right now what I'm about to say because of the low voltage that we're working with. But if it was higher voltage, it would be a good idea to have the breaker in the off position right now before you plug it in. All right, you don't want to plug this thing in with the breaker on and power just zooming into the system. Although again, in these trainers, it doesn't really matter. All right, doesn't really matter until we get into troubleshooting. All right, when you're gonna start to build your lab, then you do want that breaker to be in the off position. So let's go through that one more time. Right now, we're gonna check power, so we need this breaker to be on because that's how we are able to check power. When you are building your labs, then we want the breaker to be off while you're building, and then you got to remember to turn the breaker on so that you can test your lab. All right, you'll hear me say that in the videos, so if you forget, no worries. Reason being is if you leave this on, there's no danger. You're working with 24 volt DC. Literally, you can touch this and touch metal, put it on your forehead. It's not going to hurt you. All right, it's very little voltage. And there's 0 amperage, so there's no effect here. The problem is you can cause a short circuit here. All right, and again, this is not going to be a massive explosion when you hit metal on, but it's going to pop the fuse in here. All right, there's a little fuse in there, which if you haven't done it already, go ahead and open this little case from this end and check to see if there's a fuse in there. All right, just make sure that there is a fuse in there. If there isn't a fuse in there, then in the kit that you got with your wires, you should see some very tiny glass fuses in there. For those of you who did Code D with me, then, well, all of you, I think, did Code D with me. So you guys know about the little glass fuse that I had mentioned in Code D. So just make sure you have a fuse in there. So pop that open, give that a quick check, make sure you have a fuse in there, and then close that back up. You're going to go ahead and plug in your trainer now. Again, breaker on or off doesn't matter. You can have the breaker off, plug your trainer in. This, at that moment, this little light right here, that you can't really see it too well. I mean, obviously it looks bright, but you can't tell the color. It should be green or yellow. I think it's green. That little light's not going to be on. When you turn the breaker on, then that little light will be on. Now, if you have your breaker on and you plug this in, then that little light will turn on immediately. All right, but it's just good practice. These are habits that we want to start to build, that when we plug something in, system off, plug it in, then turn the system on, just in case, right? Just in case anything sort of weird is happening. Although, again, in this case, unlikely that any effect is gonna happen. So let's go through that real quick. One, make sure that there's a fuse inside the fuse holder, it's called. No real fancy word for it, fuse holder. Next, make sure that you plug your trainer in and then turn your breaker on, or either way that you want to do that. But we want to make sure that that light that says DC OK is on. That is telling us that we have DC power coming out of the power supply. If that light is not on, pause this video right now and you shoot me an email. All right, because that's step one and this thing is not working correctly. All right, now I will go through the prompt, make sure the breaker's on, make sure there's a fuse in there. Both of those things have to be in play, and then make sure that the light is on. All right. Actually, the fuse is not so critical for that light to be on. It's more the breaker that feeds power into the power supply. Once the power is coming out of the DC side, then it goes through the fuse first. And then you really can't see this wire. This is a wire that leaves there. It goes behind this power supply. And that's the wire that you see here coming all the way over to L1. So that wire that's leaving the fuse is the one that's providing power, get rid of that, to our L1 side. Now you can see this neutral or the negative white wire just leaving right here. Technically it's a white wire with a blue stripe on it, but I just call it the white wire. And it follows head over and it lands right there. All right, so that white wire provides the L2 side of this. So, checklist one more time. Make sure you have a fuse in there. Make sure that that green light DC OK is on. And now you can take your first check of voltage. Any one of these terminal points, doesn't matter the first one, the second one, the third one, the fourth one, or the fifth one. I have 5, maybe you have less, maybe you have 1. Actually, I have 4. 1, 2, 4. Yeah, it looks like I have 4 there. Any one of those is fine. You want to put your meter prong into that. Now make sure again that your meter cap is off, right? As you should be aware of, your meter has a little cap that goes over and the prong sticks out. You want to make sure that cap is completely off, something that you should have done when we were checking the outlets in code D. Shove that prong into that one, shove the prong into one of these other ones over here, and then look at your meter. All right, now obviously your meter has to be in a position where you can see it. Prong in one, prong in the other. Take a quick look and make sure you have 24 volt DC. Here's where the color of the wires, or leads is what we call them, coming off of the meter is going to matter. You got to make sure that the red one is in the red position, that the black one is in the black position. Make sure that they're pushed down completely into your meter. That's another thing. I had a student think that they didn't have power, but actually what happened is their leads in their meter wasn't completely pushed into the position. So make sure they're all the way in there. And now red one on L1, black one on L2. If you flip that around, all your meter is going to say, it's going to say negative 24 volts. If you put the black lead on L1 and the red lead on L2, it's just going to say negative. So we want it the other way around. All right, we want red to L1, black to L2. Again, this doesn't really matter. It's just a 24 volt positive versus negative 24 volts. It doesn't mean you have negative 24 volts. It just means your leads are in the wrong position. And that's the first check. Now, if you don't have a, let me just go through the things. If you don't have a fuse in the fuse holder and you don't have any fuses in the packet that they send you, pause this video, send me an email. If the green light didn't turn on, pause this video, send me an email. If you're at L1 and L2 and you're not getting voltage, 24 volt DC, pause this video and send me an email. All right. For the fuses and for the light here, I will contact the material people. If it is that you're not reading voltage here, I would like to meet with you first. Make sure that you're measuring this correctly. Sometimes we're, new to this, so we're not understanding exactly how we should be doing something. So I just want to make sure that you're reading it correctly. And then if it's not providing 24 volt DC, then we'll move on from there. But if this light is on, this should be wired correctly. There's no reason why it shouldn't. There should be 24 volt DC there. All right, so there's our first point that I want you guys to do. You can go ahead and pause the video now and go ahead and do that. All right, so if you did all that and everything worked out okay, that's technically the end of what we're doing with this video. However, I want you to keep everything that you did in mind first. In the event that you've built your lab and you press start on one of these buttons, there is a checklist that we want to do before we panic and go, oh no, this thing is not working correctly. Now, number one is check your wiring. All right, there is a lot of wires that are going to be going into these labs. As you can see from all of those blue wires there, blue wires going over here, white wire going over here to these points. There's a lot of things that could have been forgotten, all right, or misplaced. Put a wire in the wrong position. So that's the first thing you want to do, is just do a quick run list, checklist through your wiring. In the videos, I will provide a method that teaches you how to land the wires and check the wires off on the diagram as you're building along. So I have a method to help you wire this up so that we're not making any mistakes while we're doing it, but inevitably some mistakes are made. So that's the first thing. If the lab doesn't turn on after you press start, green start, blue start, we're going to be using both of those. First thing you want to do is do a quick visual check. Make sure the green button is pushed in. That's one you can do before you start checking your wires. Step two, make sure your green light is on. All right, one time I did have a student panic, checked, this is right, this is right. They forgot to plug the lab in. Or I think it was they plugged it into a power strip that the power strip wasn't on. All right, so just a quick visual check to make sure you have DC. Also, quick visual with your meter, make sure you have power at L1 and L2. And this is what can happen if you are landing your wires without the breaker being turned off. If you leave the breaker on, realize you put a wire in the wrong position, start moving wires around. Remember, we have positive going into things, negative going into things. If those two touch, we have a short circuit. So breaker off while you're wiring, but in our checklist of things to do, and let's write them here. First, power supply, visual. All right, make sure we have power at that little light. Very easy, the light is on or light is off. 2 is green button. All right, I think I can get it all in there. Button on manual starter. All right, that's the one on the top left over there. Number 3 is make sure that the fuse is good. All right, and how you do that is the way I taught you to check a fuse in code D. Now is when we apply it. Turn the breaker in the off position. Remember, we're going to check continuity, so off, power off. Remove, remember that was one of the questions, power off and remove. Pop open that little case, remove the fuse, have the fuse in your hand, and then we check the fuse one side and the other side, meter on continuity. All right, so I'll write that here. Just a little asterisk here, continuity. All right, if the power supply is providing power, if the green button on the manual starter is pushed in, if the fuse is good, then you go and check your wires, make sure everything is landed correctly or not landed correctly. Maybe you find the problem there. Again, it is a good idea to do all of that with the breaker off, because if you have the breaker on, potentially you can cause a short circuit as you're moving wires around. And now you've added a secondary problem. Remember what I was saying when we were talking about troubleshooting. One of the worst problems to troubleshoot is the one that you created without you knowing. All right, and that's one of them. The fuse was good when I originally checked it, but I forgot and left the breaker in the on position. Now I'm moving wires around. I found the wire that I didn't wire correctly. So now I put it in the right spot, but moving those wires around, I blow the fuse now. So now I turn everything back on, the motor is still not starting. Like, oh my God, what just happened? I found the wire. There was a wire in the wrong position. I've already checked everything else, so you don't think to check again that fuse. All right, these are all these annoying little troubleshooting things that catch us in the end. So if we just take the time to, anytime we're gonna move a wire around, shut the breaker off. You don't have to unplug, shut the breaker off, move your wires around, turn your breaker back on. All right, it's not gonna affect anything to on and off this breaker multiple times. Control breakers are control breakers for that reason. Standard breakers are not good to do that, by the way. On the panel, those are not built to on off. They're not switches, but these are designed for that. All right, I think that's everything that I want to cover. So again, right now what you want to do is a power check. Make sure that there's a fuse in the fuse holder. Plug in your lab. Turn your breaker on. Make sure the green light is on. That's telling us all of this on this side is good, and then meter to L1, meter to L2. Make sure again your meter is on the DC position. Make sure you have 24 volts there. If you have 24 volts there, then we're ready to move on to starting your labs. All right, I'll see you guys in lecture. Have a good one.